Hello everyone, welcome to Native Mobile Bits. In this video, we are going to revise Java programming language. We are going to do hands-on coding. In this video, we are going to implement different programming concept which can be similar in Java and Kotlin. There are many concepts which are similar, most importantly object-oriented programming language concepts, and these concepts are kind of similar in Java and Kotlin, but implementation can be different, right? But we are going to understand the concepts while implementing. So I'm thinking to start these kind of videos where we will take a topic and we will try to implement different concepts out of that. It can be like in this video we are picking Java and we will try to implement as much concepts as we can. Then let's say next video we can pick Kotlin and we can try to implement multiple concepts there as well. Okay, then we can pick Jetpack Compose and try to implement different concepts out of it. So you can say it's kind of a revision or crash course kind of series where we will pick important topics and we will try to implement the concepts out of it. Okay, now let's start today's video, and I'm calling this video as Java practice session because I know that mostly all of you know Java, but time to time we should revise our core technologies or our core concept. That's why I am recording this video today. And to start Java practice session, let's start with creating a simple Java class. And to create a class, we can just use this keyword and we can just name the class. And for now, let's start by creating a class called engineer. Okay, this is the basic syntax to create a class. And when we want to write a piece of code in a Java program, we need to start with main function. Okay, and the declaration should be like this: public static void main. Okay, this is the main function and it will take string arguments. Okay, this is the declaration which will make sure that JVM understand that this is one class and it has the main function. Okay, and this main method is going to be the starting point from where JVM will start executing our program. Okay, JVM will not execute the code if our program does not has this main function. So this main function is necessary. This is the basic syntax where our class is there and we have one main function which is the entry point for our Java program. Now this main function has multiple keywords. We need to understand this concept clearly, and this keywords public, this is called one access modifier, and this public access modifier specifies that who can access this method. Right now this is our class and we have one main entry point, but JVM should be able to access our program from outside our class, right? So when we mark this main function as public, that means everyone has access of it, and from outside JVM can also access our program. Okay, this is the public modifier here. Then next we have the static keyword. And why we need a static keyword in a class or in our main function, that is also very important concept. So when JVM want to access our class from outside, JVM should be able to directly access its method also, its variable also, right, without creating any object of this class. If we specify our main method with the help of a static keyword, that will make sure that JVM has access to our variables and methods from our class. Okay, that's why we use a static keyword, because when we make a method as a static method, this is becoming a class related method. Now the main method is static, so JVM will be able to access it without creating one instance of our class. And let's say if Java does not follow this practice using static in main method, so what will happen? JVM will need to create one object of our class, and that will be the unnecessary wastage of memory, right? Because every time JVM try to access a class, JVM should be forced to create one object. But when it's static, so it's class related, so JVM will be able to access it without instantiating the class. That's about static. And the next is void. So this main method does not return anything, okay? And void is a keyword which is used to specify that this method does not return anything, okay? This main method does not return anything. That's why we have added void here, okay? Main is the identifier for our entry point. So JVM, whenever JVM will try to access our program, JVM will try to start searching for this main keyword, that where is the entry point, okay? So this is the identifier for the entry point. Now that's about our basic Java class and main method of a Java class. Now there are few questions. Can we add integer or string as a return type for our main function? So we can, but JVM will not be able to execute the program. It can compile though, because if we add a return statement here, let's say 10, so it will compile, but it will not execute because there is no main function. But why it will not execute? Because JVM has a specific syntax to define the main method. It should not return anything, and then we will be able to execute this, okay? Is this main function necessary inside a Java program? Can we execute the program without the main function? So the answer is no, because compiler will search for a main function that is going to be the entry point for a program. Now let's cover strings in Java. So in Java, string is a very important topic, and string is a class which can be used to store a sequence of characters. In Java, there are two ways to create a string variable. First is to use string literal, and if we want to create a variable using literal, we can just use string name. We can just pass the value here, and our string variable is created, okay? This is basically to make Java more memory efficient because no new objects are created if it's exist already in the string pool, okay? So we have a string pool in Java where all the string variables are stored. So let's say if we are just using direct value, that means we are using a string literal, so compiler will check in the string pool. That means compiler will check in the memory that do we have this row stored inside memory. If it's stored already, compiler will not create a new variable and will refer to that. If it's not created, then it will be created in the memory, okay? Second way is to use a new keyword. Let's say we are creating a new variable last name and we are using new keyword. So this is the syntax. Here we can pass the value we want to store, and now these are the two different way. But when we are using a new keyword, so in this case JVM will create a new string object in normal heap memory, okay? And then once this object is created, JVM will take this value which is a literal, and this will be placed in the string pool. Now here are two different methods, very important methods. If you want to compare, let's say if this last name is equals to name, so compiler will check the value. Let's try to print the result. So compiler will check the value when we use this equals, so values are different, so it is giving us false. Now let's create one new variable, another name, and we are using this time literal, okay? So let's see what will be the result when we try to create a comparison between this last name and another name. Value is same, okay? So we can see the value is same, so it is giving the result as true. Now, if we try to use this operator, let's see what will be the result. So we can see the result is false because these two variables are created at two different memory location. That's why the result is false, because this operator tries to compare the object reference, and there are n number of methods in a string. This is the very basic and common question. Now let's comment this. Let's see how we can take input in Java. So we can use scanner class. Okay, let's import this, and we need to create one new object of a scanner. We need to provide system.in. Okay, this is our scanner class object, and with the help of this we can take multiple things like next int, we can take next float. Okay, we can also store these in int number, and if you want to store this, let's say, okay, like this, we can store the variables, and then obviously we can print out. Now we will get the output. So let's rerun the program. 10 3.4, so it will give us the value, that number is 10 and float is 3.4. This way we can take the input. This scanner class takes input of primitive type and strings, but let's say we want to read a character stream, so we have another class which is called buffered reader. We can use one variable, and with the help of new keyword we can create one object of this buffered reader, and this will take one object of input stream reader. Okay, and this takes system.in. Okay, let's import this one, and with the help of this buffered reader we can just use read line like this, and it is telling us to add IO exception, or we can surround it with try catch here, and we can try to print. Now if we try to run our program, we will be able to enter anything here, like this is 5 and 4.5 or something, and this buffer reader class will read the entire line. It can be string, integer, or it can also contain a float or anything. Okay, and we can see that our output is printed. So there are two ways: either we can use a scanner, or we can use buffered reader with the help of input stream reader. To separate these examples, I have these different classes. I will also push this at GitHub, and I have renamed this with Java Playground. So for this main.java, this also, let's try to refactor this. Okay, this is going to be our main file for now. Let's close other tabs, and now we are going to start learning or revising about arrays in Java. Okay, so an array is a collection of similar type of objects. If you want to store multiple variables, it can be integer, float, or any primitive types or any reference type, we can store in a single variable which can be referred as an array. Okay, so to define an array, let's start with defining a single dimension array of integer type or primitive int type. So we can just use int. Okay, we can say numbers, and then we can define the values. This is our primitive int type array. If we want to store, let's say, float, we can say float numbers. Name can be anything based on our requirement. We need to assign with f, 2.4 f, 3.4 f, and so on. Okay, this is the simple way to define one single dimension array of primitive int or float type. If we want to define an array of integer type, so we can just use integer, and we can call it, let's say, a, and we can assign the values. We can also define arrays of reference type or custom classes. So let's say we have a class fruit, okay, and in this we have a variable string name. We can create one public primary constructor which can be fruit, and it can take fruit name, and it can update the value with the given value. Okay, this is one very basic fruit class. If we want to create an array of this, we can create like this fruit array. We can name it as fruits, and we can name it as fruits, and we can pass the size. Okay, so let's say we want to just create an array of 2 size, so we can assign fruits 0th with new fruit, and here we can pass the fruit name, let's say mango. We can do the same thing for the first index. In array, index always start from 0, so this is the first element, this is the second element, and here we can pass the value. And like this we can create an array of custom class as well. Next we are going to cover two-dimensional array. So if we take a closer look, two-dimensional array will have an array of arrays. So if we want to define a two-dimensional array of primitive type int, so we can just use this syntax. We can just name it as array of numbers, and we can define with new int. We can define the number of rows and the number of columns. Okay, so we are defining this array of numbers of primitive type int, and we are saying that we need 3 rows and 4 columns. That means 3 rows and 4 columns. Now to initialize our array with values, we can just use the name of the array, and we are assigning the value at 0th position of row and 0th position at column, let's say 1. Okay, similarly we can do that. How many rows are there? 3 rows are there, so for first row we need to assign 4 values, 4 columns, right? So with the help of this we can assign. Then we want to do the same for 3 rows. Okay, so let's say for second row we are assigning here, and here we are assigning for third row, and value also we need to change, let's say okay. Now if we want to print this array of numbers, so we can just use system dot out dot print ln, and we can use arrays dot to string. We can pass the name of the array, and it will give us the reference. Let me show you. It is giving us the location of these 3 different rows, etc. If we want to print the value, we can use deep to string, and this method will print the actual content of these rows. Okay, so we can see that in our first row, for all columns we have 1, then for second row we have 2, and for third row we have 3. Okay, this way we can create two-dimensional arrays. Now let's move towards object-oriented programming, and this can be similar in so many terms with Kotlin examples as well, so this is very important. Let's start with very basic. So we already understood that this is a class. In Java we have everything distributed in between classes and object. Okay, classes is kind of a blueprint for other objects to be created. Okay, we can create multiple objects out of a class based on its defined pattern. Okay, so let's say we have a class and we can have multiple variables here. Let's say string language Java. Okay, we have one variable, and then we are having one integer, number of examples covered. Okay, let's say 10 for example. We have these two variables, and if you want to create a object of this class inside our main function, we can just use its name, and we can say playground, one name for our object. We can use new keyword, and like this we can create one object. Now we can access the value of these variables out of our class with the help of this object. Okay, how we can do that? With the help of system.out.println, we can just access playground dot language. Okay, and with the help of this object we can also access the second property. Okay, if we run, we will get these values printed. Now let's try to learn little bit about how we can extend the properties and methods of one class into another. For example, let's say we have another class, literature. Okay, and this class can have one variable, language used in coding, and this is English. Okay, for now we are having this class, and we are also having one function, one method, which is get data. And this function is not doing much, but it is just having a print statement, and it is printing is used in all examples. Okay, I have this simple function and one variable. Let's say we want to access these things without writing this exact duplicate code inside our Java Playground class. So we can use extends. Okay, and we can write the class name literature. Okay, so now Java Playground class is extending literature class. So Java Playground class can access this variable and this function with the help of Java Playground object. How we can do that? With the help of playground. This is the object of our Java Playground class, which is extending the literature class. So with the help of playground, we can access language used in coding. Let's say we try to print this as well here. Alright, and in the next line, with the help of Java Playground object, we can also call this function get data. Okay, now if we will run the program, we will see that whatever we had in this literature class, we are able to access inside our Java Playground class with the help of Java Playground object, only because we have extended another class. So this is one very important functionality in these programming language, where if we have something written at one place, we can access that in another place by extending that class. Now here comes one important concept, which is called subclass and superclass. Now this superclass is the class which is extended, and subclass is the class which extend the superclass. This concept is called as inheritance, and in inheritance one class inherits the properties or variable from another class. Like here, our Java Playground is inheriting this property and this method from literature class. So this concept is called inheritance, and inheritance has two things. This is subclass, which is extending the superclass literature. Okay, in Java we also have support for multiple level inheritance. This is single inheritance, where one class is extending another one. How we can support the multiple inheritance? Let's say we have one interface. Okay, and it can be anything. Let's say history, and this interface can have some method. Let's say void important data of history. We no need to define the declaration of this method. Declaration means we have this declaration in between these curly braces, right? For every method we define one method, we define some declaration. But when we define an interface, we just define the method. We no need to define the declaration here. Okay, now let's say our class Java Playground, which is already extending the literature class, can also implements this interface which is called history. Now the moment our Java Playground class implement history interface, we need to implement the declaration for this method. Okay, the moment you do this implement methods, you will see that we have one overridden method which is important data of history. Here we can define something based on our need. Only one statement, print statement. This is very important data of history. Okay, this way we can achieve multiple inheritance, one with the help of extending the superclass and one with the help of implementing history. Like this we can implement multiple interface as well. If we have another one, let's say this, I'm not renaming it, but so we can see that we have another method as well from this second interface. This way we can achieve as much as reusability of code with the help of implementation of interface and inheritance. Okay, now let's learn about polymorphism in Java. So this polymorphism means having different forms. So now we have one class Java Playground and we have one interface. If we implement this interface here, so we'll be forced to implement this method declaration here, right? So you can see that this is happening with the help of @override function. This is called runtime polymorphism, where we can just override one function from another interface or another class. In this example, you can see that we have one Java class, Java Playground, and this is extending one coding test class, and it is also implementing one interface coding practice. Now the moment we extended and implemented these things, we are able to override this method test and practice, okay, which is coming out of our class and interface. We have these methods here with the help of override annotation. So this is called runtime polymorphism or dynamic polymorphism, okay, where one class can extend the method from another class or another interface. So in simple word, overriding means when we take the method or some functionality from some another class, from superclass, right? Because this is the subclass and this is the superclass. This is called method overriding, and which is also known as dynamic or runtime polymorphism. Another part of polymorphism is compile time polymorphism or method overloading. Okay, if we have a class and we have multiple methods of same name, that is called method overloading. Let's consider this example and let's try to implement this concept called method overloading. And now let's try to cover this method overloading. So you can see that we have multiple methods with the same name but different type of parameters. Here we have int, here we have float parameter or double parameters, or different number of parameters. Here we have 2, here we have 3 of same type. So this way we can achieve method overloading if we have same name of methods but with different type of parameters or different number of parameters. Okay, and then with the help of our class object we can access all of these methods. This is called compile time polymorphism or method overloading. Now let's start taking a look at different modifiers. So we have multiple modifiers like public, private and protected. In this example, we are going to cover about those. For now, we have these two different classes, Java Playground and example. Let's say I extend this example class here and I create one object of this Java Playground class which extends example. So I should be able to access this variable a with playground. We can store it in a variable or print it. We should be able to access it right now because by default it is public. But let's say we specify public, then also we will be able to access it. But if we try to make it private, then there is this error that A has private access. This variable is having a private modifier, private access modifier, so we cannot access it. Another thing is protected. If we have this variable A as protected variable, still we will be able to access it, but within the same package. Within this same package, if we have a protected variable, we will be able to access it. But if we have classes in different package, this protected variable will not be accessible. Now, one another thing to note here is we can simply extend this class. Let's say if we make it final, we will not be able to access it because final classes cannot be extended. Alright, and the same thing goes for this variable. Let's say our class is not final, so we can extend it, but this variable is final, so we cannot change the value of it like this. But if it's not final, we can change it. If it's public, we can change it. If it's private, first of all we will not be able to access it, but if it's protected, then we will be able to change the value. Okay, so this is little bit about modifiers. Now let's learn about abstract classes. Okay, so to define an abstract class, we need to use an abstract keyword followed with the class keyword and then the name. So let's say we are defining an abstract class shape. Abstract class is a special class which can have method declaration without body and method declaration with body as well. Let me show you. Let's say you want to define a method draw. Okay, and you can just add abstract keyword and you no need to define the body like this. Okay, and if you want to define a method which can have its own body as well, let's say details. For now I'm adding a print statement, details method is called. So we can see that abstract class is one special kind of class. It can has method without body and method with body as well. This is the main difference between abstract class and an interface. Let's say we have an interface and let's call it shape interface. Okay, I'm calling it this, and it can has a method without declaration. Okay, but if you try to add this method with declaration, you cannot do that with interface. That is the main and important difference between abstract class and interface. Another very important thing, let's say we have a class, we have its main method. We cannot create instance of this abstract class. Like if you try to do this, only this, you cannot do that. Now let's cover one basic example of encapsulation in Java. Encapsulation is one very important concept where we hide the internal state of an object, but there is some data and some methods which typically perform on that data. Either we can set the data or get the data, and this typically happens in a class. So we can have a class where we have some data and we have some variables and we are just having the getters and setter. We are just hiding the internal state of that object and we are bundling the data and some methods to typically perform on that data itself. Okay, so let's say we have a class and we have a class called person. Okay, so it can have age. All right, it can have a variable for name and it can have some getters and setters. We can have some method, let's say public void set name, and we can just pass a string of name. Okay, and we can update the value of name like this. We can have a method of string return type get name, and it can return name. Okay, this is one getter and setter, and for the age variable we need to do the same thing, public void set age. We can pass integer age We can pass int type, primitive type, and we can just set age. Then one another method to get the age. Okay, and this will be of integer type, get age, return age. Okay, so this is one very basic example of encapsulation. We are just having two variables and we are having respectively setters and getters. Okay, now let's say we have one main class, main example, and inside this we have the main method. Okay, let's say we create one object of that class. How we can do that? We need to just take person new person. Okay, and then with the help of person we can just set age, let's say 20 years. We can set name as well, and we can set here Virat Kohli. Okay, we can also access the data. I'm just trying to use within the print statement. We can access person dot get name, and same thing we can do for get age. Okay, so this is our encapsulation concept example. We have a class where we are having some data and we are having some method to control that data. Either we are setting it or we are getting it, right? Now we can run the example. So we can see that we are creating one object of this encapsulation unit, and then we are setting the data and we are accessing the data. Alright, so this is the encapsulation concept. That's it for today's video. I hope you enjoyed today's Java practice session. We have covered multiple core concepts of object-oriented programming, and I know that we have chosen Java, although we are almost everyday coding in Kotlin, but I just wanted to touch base once again with Java so that we are still familiar with the concept. So I hope you like this video. If you enjoy this, please like, share and subscribe to my channel. I will see you very soon in the next video.